man, this is really living.
We're committed to the art and nothing stop us, not even a train, plane, tractor, all of us as we feel the rhythm inside the marrow of our bones.
Hey guys, Bukulate here. I'm going to give you a video. Hey, I come across an article here, guys, from NASA. And I know there's a lot of back and forth on the whole organization there. I have my own opinions. Some good, some bad there. But I found this article very interesting and very kind of enlightening, actually. What it's talking about, guys, is this MMS, which was basically just a mission that they were using high resolution instruments looking out into stuff, and they found they actually caught an interplanetary shock. Now, you guys heard me say the word interplanetary before. I use that word when I say interplanetary magnetic field lines. Okay, it's when I show you that magnetopause model. Okay, and it shows you the lines. The blue lines are our connection to the sun and other celestial objects. You guys have heard me say that. That's the interplanetary magnetic field lines. It's our connection there. Okay, so they're using the same verbiage here, interplanetary. Okay, that's important to know. Okay, so basically what they're saying here. First off, what is a shock? Well, this interplanetary shock, what it is it's a solar wind that's moving at a certain speed, and then a faster solar wind catches up to it. And when they collide, it causes this shock. Okay? Now, you guys can go on and read this whole article and stuff. And I'm just going to be honest, I don't understand the whole article itself, okay? But I do understand a majority of it. And they're talking about like a difference between kinetic energy and electromagnetic energy from electromagnetic fields, okay? Now, we talk about this a lot. Okay, we talk about how the Planet X system interacts with the sun. The two electromagnetic fields there interact with each other. We've been seeing these disruptions on these models. Okay, and we've talked about this. Are they cosmic rays? Are they actually solar winds, or what? What's going on here, right? We've been trying to figure that out, and we think the majority of them are coming from the interaction between the Planet X system and the sun, plus the cosmic rays, when we see the rogue disruptions on the models, okay? Because if you can't track it back to the sun, you can't call it solar wind. Okay, it had to come from somewhere else. So, we're going to see more cosmic rays right now anyway, guys, because the sun's in a weakened state in the minimum. And when that happens, its magnetic field is weaker. Its magnetic field is what stretches out to the end of our solar system. Okay, it protects our solar system, just like our magnetopause, our magnetic field, protects us from the sun's energy. Well, the sun's magnetic field protects the solar system from the cosmos's energy, like cosmic rays. Okay, so more cosmic rays are going to make it through when the sun is weaker. That's basically what I'm saying. So the chances of us seeing more cosmic rays is greater when the sun's in a minimum. Okay, so anyway, they seen this shock. Okay, so this is pretty much saying that it's possible that those disruptions we're seeing could be caused from electromagnetism, okay, the disruptions, because this energy is like traveling that way, like we've talked about. Okay, it's causing these energies, it's different, it's moving different, it's acting different, it's not kinetic like they thought. So, there's a little animation of some solar wind. We're not going to watch that because it's just animation, it's not even a real capture. But this right here is what they caught. Okay, and what are we looking at? Well, you'll see like a darker area show up, and then it catches up to this other darker area. And when they meet, that's when the shock happens. You'll see it expand out. Right there. Okay. Here it comes in, top, boom, out. Right? That's the shock that they're talking about. And it's electromagnetic. It's not kinetic energy. And we could talk about kinetic energy for a very long time, but we're not going to, because it could be a whole video and a whole series, actually. But anyway, I wanted to show you guys that, because it does give a little bit of validity to what we were talking about. You know, when the Planet X object does get in certain positions when it's closer to the sun, and it does react. And we do see these, interruptions on these tools that can't be tracked back to the sun, so we can't call it solar wind. The tools only know that it was, charged particles. They can't tell you what the source was. Okay? So that's why we were talking about that. But I'm going to pause here, guys. I'll be right back with you. All right, guys, back with you. So what we're going to talk about here, guys, is Scott's going to go into something here that I'm going to add my 2 cents to at the end here. Actually, let's just listen to him first.
What it looks like outside when the so-called sun is up there in the sky. It's about that time of year here in the northern hemisphere where when you're outside on a sunny day, doesn't everything look like fluorescent light?
Okay, I'm going to stop it right there, because he said pretty much everything right there. He goes on to talk about it just a little bit more. I'll leave a link to this live stream. Guys, go check it out, because he's given an update. It's basically his final update on the smart meter thing he's been talking about, and it's very, very good information. He actually shows you how to protect yourself from those things very, very cheaply. It's just a material that you buy that has an adhesive backing. And I can tell you right now, if he's going to tell you that that's a good product, he does his research, and I promise you that it's a good product. Okay? He shows you in his video here, all right, that all those readings went straight down as soon as he put this little thin adhesive backing material on these smart meters. Okay? And it was like $20 or less. So we could all do this. Anybody that has these things, please do yourself a favor, your family, your kids, go get this stuff. All right? Seriously. And he gives you guys a website and a company to go check out. They do a lot of products. I'll let him tell you about all that. But back to what he was saying here. This is a conversation that everybody's having right now. Not just in this circle, not just in this research. Okay? I would challenge you guys to go sit in a mall somewhere, or Walmart even, and listen to some of the people's conversations as either they walk by or, sit on a bench like an old man does while his wife shops or whatever. Okay? And just listen to people. You'll learn more about that and learn more about life than you ever could learn from, being on your smartphone. That's for sure. But anyway, they're having these conversations about how the sky looks different. All right, and and I have these conversations with people, and I never start them. Most people have these conversations, but don't even know I have a channel. They don't know I do this research. Okay, and I do that for a reason. It's not because I'm ashamed of my channel or what I'm researching. It's because it gives me more of an honest answer. These people have no reason to tell me or talk to me about this stuff unless it's actually what they're seeing. In other words, they're not just going to come talk to me about a subject because they know I like the subject. They're going to say it because it's actually valid. And that's what's happening. My wife, my family, just my friends, my coworkers, they're all saying the same thing. Why does the sky look like that? What's different? Okay, they're noticing something's different. Well, it's a couple different things, guys. It can only be a few things, actually, if you think about it. Either the light source has changed, or they've put something in front of the light source, or the atmosphere has changed. Okay? So, in my opinion, majority of all that is all true. at some level. Okay, we talk about the chum trails, right? That can be a big part of it. But, Scott was talking about fluorescent lighting. I worked in printing for 20 years. We did what we call graphic changes. We made food containers, okay? And what I mean by that is we made Cool Whip bowls, Dannon yogurt, Country Crock butter bowls. So anytime they wanted to change the graphics, okay, on those bowls to like something new, like, hey, we have this new product, let's do this, right? So they would come in and we would make specific, like, I guess you could call them sample bowls. And we'd try to make them look exactly how they wanted them to look by adjusting the intensity of the ink, how much ink we're putting on them, all those kinds of things, right? Well, when we did that, we would take these parts to what we called a light box. And the reason why is because inside my factory, it was halogen lights. Okay? So we had these light boxes that you could put the parts underneath because, believe it or not, when you change the light source, you can make something that is red look almost green or purple just by changing the light source. And I'm not going to go into optics and how the light goes through the ink and actually bounces off of the bowl and then back through the ink, and that's what you see. Okay? It hits the substrate, and again, that's a whole nother, doesn't really have nothing to do with what we're talking about here, but then we got to, like I said, we could flip that lighting just by flipping a switch. So I can make it look like as if I'm standing in the grocery store. We called it grocery store light. Basically, it was fluorescent lighting of some sort. Just how it was, muffled out or diffused. We could change it to UV light. We could change it to fluorescence like Scott was just talking about. And it all looked different each time you would change the lighting. So that's my point. Something's changed because the sky looks different. Not just the sky, but the surface now. Okay? The trees. Do this. Go outside. Look up at the trees. Look at the leaves from the bottom up. Okay? This is what I was just talking about, the reflective light, because that's what's happening there. The trees are looking different because the light that's shining through them that you're seeing is different. So it's changing the shade of the colors. The green probably isn't as intense as it used to be. It's more yellow or dull. It's not because the tree's dying, it's because the lighting is actually different. Okay? So, with that being said, we talk about the shadows, which is what he was talking about here. When I was a kid, I remember 12 o'clock was always what we talked about, noon. That was when you would not, that was when you would have the littlest shadow. Whether you had a shadow or not, it was going to be the littlest it was going to be all day long. Because the sun was supposedly as close to straight above your head as it was going to be all day long. Well, if you go outside, guys, I would challenge you guys to see how long that time frame is now. Okay? You're going to notice that it is definitely bigger. Now, why is that? Well, again, it's because the lighting changed. Not because the sun is staying above our head longer, but because of what they would call like stage lighting, studio lighting, that kind of thing. That's their goal, is to get rid of the shadows. So they're able to use different styles of light to get rid of the shadows. Because if you take a regular incandescent light bulb and you shine it on something, it's going to give a different shadow than what a fluorescent light will. The shadow is going to be a different size. You guys can do that little experiment yourself. It's not hard to do. Just hang a ball somewhere and take a flashlight and move it around it and watch how big the shadow is on the ground. And change the light source. That's all you have to do. It's very simple. You'll see it immediately. Okay? But anyway, what I'm saying is that that's actually happening. Okay? Now, I'm going to pause here and go to another YouTuber's video, somebody that I'm going to talk about here. It's Mystic Skywatcher. Madame Mystic Watcher right now is the name of her channel, but she's changing the name. She just can't change it until YouTube lets her. But we'll talk about that here in a second. Hold on a minute. All right, guys, this is her channel. It's Mystic Skywatcher, but as you can see, her name is still Madame Mystic Watcher right now. but she will be changing her name. But anyway, she was having a conversation with her husband, and I'm gonna show you her video. She's very honest, guys. Go watch her video. She does some really good stuff over here. She'll show you the paintings and stuff that she's been doing too here, and it's good stuff. She's obviously very talented. But she's having a conversation, and you guys have to keep in mind that none of us, I haven't talked to Scott verbally today at all. I think we've texted back and forth a couple times, but this never came up, okay? And the same with me and Nicole here, and Nicole and Scott. They haven't talked about any of this, but yet the conversation is still the same. So that should speak volumes, guys. Okay, that's telling you that something's different. This is not something that is just being put out there because it's part of the conversation. This is something that we need to address and really dig into because, and again, I got to bring up Jeff P. because he does a great job on all the sun simulation stuff, all the blue beam stuff, holographic stuff. I mean, just go watch his channel. That's all I can say. He's an awesome dude. Go check it out. But we're going to watch the first minute or so of this video here.
Hello folks, it's August 9th, 2019, Friday here. I'm posting this, and I'm outside of Atlanta, Georgia. If many of you are my followers, subscribers, then you know. Okay, I have some interesting things. I've been painting the last few days, so here for my viewers, there's some of my paintings. But back to what I was saying. As I was painting here, and watching the latest video published by Scott here on Planet X News, he's explaining something that I just explained to my husband a few hours ago over dinner.
Okay, did you guys hear that? I mean, and she goes on to talk about what Scott was talking about here a little bit. She has some stuff to add. She was talking about the shadows and stuff in her backyard. You guys need to go watch it because it's very enlightening. It very much helps explain what's going on here. But what I'm trying to say, guys, is that this is all over the place now. This isn't just something that we're talking about in this community. There's a lot of other people talking about the same thing we are. They just don't know it yet. And it's up to us, those of us that do these videos, and even those that don't do videos. It's up to everybody to try to bring everybody else along. And that leads me into saying, I really have to give credit where credit's due. And Scott doesn't need my help at all. Okay? He doesn't need me to say anything good about his channel or him. Okay? I say it because it's deserved. I want you guys to know that. He's the one that has spent the most time trying to help me. And I think that I'm better for it. I think my channel's better for it. I think you guys are getting better information, better correct information because of it. Because he has taken the time to try to help me. I do still get things wrong. And, one of the biggest things I respect about him is when I do get things wrong, he's not afraid to tell me. Okay? And it's not because he wants to be mean. You know what it is? It's the exact opposite. He doesn't want me to continue to say something that's wrong over and over and over again and then have to come back and tell everybody that I was wrong after I said it 5,000 times. That's actually helping me. Okay? That's not hurting me in any way, shape, or form. And it's actually helping anybody that's listening to me get the correct information. That's how we have to look at this kind of stuff. And he even says it. Okay? People consider him very abrasive sometimes. I can tell you just from knowing him outside of this YouTube realm a little bit and being able to have a personal, conversation, that man would do anything for anybody if it was going to help him. Okay? I promise you that. That's all I can say. I mean, I can't say much more than that because that's just the truth of it. I don't know what else to say. He doesn't need my help, so why would I? I just get stupid comments, and that's why I'm addressing this. You know, people say I'm so far up his butt or whatever you want to say. Well, I'm just giving the due respect to somebody that is actually given his time to try to help me, in turn help you guys and anybody else that watches my stuff have the correct stuff. I mean, he's doing it for the right reasons. I don't care how he does it. I really don't. Okay? I've had to learn how to grow some thick skin as I went through this process of, trying to do what I do. And I've learned that the people that are actually going to help me are the ones that are going to just tell me when I am wrong and tell me the truth. Not just say, hey, nice video, great job, and move on. But don't tell me where I got it wrong, because then I don't get any better for that. So I just wanted to point that out, guys. And I think he's trying to help Nicole here too. And I'm going to try to help her as much as I can, as much as I know, because she deserves it. She's trying to do what she's doing. Okay, so guys, go check her out. I mean, honestly, it's good stuff. She's a very honest person. She seems to have a good heart. She has a great family. Her and her husband were talking about this. I mean, any husband that's going to cook dinner for their wife is a good person, right? I do it for my wife. I hear Scott talking about cooking pasta and stuff for Claudia all the time. So, I mean, it's it's what it is, guys. But check them out, for real. This is a good video. I'll leave a link to both, guys. I'm going to pause here for a second. All right, guys, I'm back. I'm going to give you a little update here on these models real quick. I'll give you at the end of the video, guys, like I've been doing. I'll show you guys, just give you a little time lapse of what's going on and show you all the different models. Try to put some music to it. Anyway, I want you guys to look at that solar wind. Okay, that's pushing up there. Okay. Something else that I've noticed here, and I've talked about this before, is this openness. Okay, you can tell that that's definitely different than the rest of it. Not to mention, this little light patch of blue is kind of interesting. Okay, that's low intensity around that other stuff. For it to be right there is kind of odd. That's all I'm saying. It's not. Like I said, it's probably not a big deal, but definitely something that we can look at. Now, I'm going to run this through real quick. Now, watch up there, like I showed you guys, the solar wind. You're going to see it move around. Okay, you're going to see it 480. Not to mention, you're looking at the model itself. It's acting. And obviously right there, we're getting ready to get hit with something. I found this particular capture here interesting because of the arrow directional. Okay, yeah, that's kind of weird. But as you can see, we acted a little weird in the back at the same time when we're getting ready to get hit in the front. How can I tell? Well, look at the intensity in the front starting to change color, and then see the waves come. Look at that. We got hit right there because we compressed. Okay, and I've explained this before. See a little bit of red coming right there. See that orange? Look at the solar wind speed when that happens. Goes into the 6s. 685. Okay. And then we get hit. And like I said, and this happens really, really fast here lately. These are like really quick hits. They're not long duration, I should say. Okay. So as we're going through here, back up in the 6s, which there's an 822, guys. Okay, what I find odd about that, now check this out. This is what struck me kind of nutty frutty here. Okay, this is why I keep going back to this electromagnetic transfer of energy. Okay, now if you look at these arrows, can you guys see how chaotic that is? These arrows typically, they should be, all of these behind the Earth should be pointing straight back. Okay, now when we get disruptions or what have you, you'll see spirals or what have you and other things. But for this to look like this right now, I mean, when you see one of these arrows this far away on the backside of the Earth pointing that way, I mean, it takes a decent sized disruption for that. And then you see, you know, arrows pointing directly opposite of each other, right next to each other. What I mean by that, if you look at these two right here, one's pointing that way, one's pointing that way, and they're right next to each other. It's just like a tornado radar sensor. That's what, when you see a velocity model, when those are next to each other, they call that a tornado. And you see red and green next to each other like that. It means they're moving in opposite directions. So it's indicating some sort of a cyclonic motion. But if you guys look at this, I mean, yeah. But what I'm finding odd, see that says 611? Okay, and again, I've already shown this, but it keeps going up, right? Now you tell me, this is what I find extremely odd. Now remember back here, this is what happens when we get hit with strong wind, right? We see the hit in the front. You see that? Now, and then got hit again. Okay, so we're up here. This is the signature I was just showing you. It went from 614, 638. Okay, you see anything in the front? I'm not seeing much, right? No color change. Well, tell me how it goes to 824 right there, with nothing changing in the front. Where did that come from? How did that speed happen? Right there, with nothing happening in the front. Okay, at least nothing visual. Okay, and it took it that long for it to react. Now, again, I'm going to say this too. This particular signature right here is very odd. Look at the shape of it, kind of an hourglass. You see arrows going all different directions. You see different colors here. I mean, that's all indicative when we do get hit. But, you know, for us to jump up to 8 something, now there's a 9. Look at that. 908. And really nothing big going on in the front. Okay? And I can tell you, because I've already went and looked at the density models, that the density wasn't up either. So what's causing that? Why are we seeing these disruptions? Why are we seeing the increase in solar wind? You know, what is causing this? Is this coming from a coronal hole? Is this something they predicted? You know? That I don't know. We're going to go look, though. Okay, guys, got you over at Space Weather here, right? Okay. You can see right here that that's even an increase for this model for sure, this page. Sometimes that gets up to 6, 7. I've seen an 8, even 1,000 once before. But that's all kilometers a second. But this particular one's reporting 557 solar wind speed. Okay, now, so what do? We look at the KP index, right? When we're seeing if we're under any kind of geomagnetic storm. Well, it looks like we had a slight increase right there. Up to like a level 4. Or is that a 3? I think that's just a high 3 right there. But yeah, so that would be considered like increased activity, but it wouldn't be considered any kind of storm. So yeah, and that's what we're seeing. I mean, that's what we're seeing on the models, because we're not seeing anything huge. But look at this. This is actually a historic model. This shows you what's happened. All right, this is the ACE. Now, the yellow line is the solar wind. So you can see that right here it spiked. All right, now the density pretty much stayed the same and actually kind of dropped a little bit. So why did we see those disruptions? Well, the speed went up, right? Well, if you look at the time frame here when that happened, you see the 00. That means that is the first hour on the 10th is when that spiked. Okay, so guess what we can do? We can go over here. We can look at the Enlil model. All right. Then we look at the dates. Okay, you see this green? Oops. Okay, the green line here on the bottom is the conditions at Earth. Shoot. I hate that when I do that. Sorry, guys. Come on. There we go. Okay, so that's conditions at Earth. Here's the 10th. This line. This model is showing a decrease, not an increase in the velocity. So why is this model showing an increase? Because it is. At the exact time it's showing a decrease on the other model, this model is showing an increase. And this is on the same page. This is on the same space weather page, guys. These are right next to each other. These are two different models, okay? But they're right next to each other. And they're saying opposite things. So what I'm saying is this right here, it's showing our solar wind speed should be coming down in a consistent way and kind of staying there. Up here's the density. We're not even talking about that right now. We're talking about just purely wind speed. So where'd that wind speed come from? It didn't come from the sun. You wanna know how I know? Because if there was a coronal hole causing that, this model knows that. Typically, when there's a coronal hole, this model will this will show an increase in the wind speed. This is trying to predict 5 days in advance. Okay, this down here tells you when this model was created. This was created on the 10th. Image created. This is what really puzzles me. Okay, this was created on the 10th at 5:36 UTC. Okay, roughly 2 hours ago. I mean, come on. They completely missed it, is what I'm trying to say. We've seen an increase, a massive increase. We've seen it up to 800. Even on the ACE model was showing 700. So why is the velocity on this one showing it going down below 4? And staying there. There's not even a spike. So that's my question. That tells me that they weren't expecting this. So it came from somewhere else. It didn't come from the sun, guys. Unless we had a flare. And I went and looked and I didn't see anything. I ain't saying that I didn't miss it, but it's possible. So I'm going to pause it. Alright, guys. So I'm going to show you what I do here when I see stuff like that. I come here. Okay, this shows a bunch of different things. And I show this a lot, at least at the end of my videos. Electron flux. Okay, if you look at the model over here, you can see there was a spike of something right here. Okay, the electrons spiked right there. So, did anything else react? What's going on here? Well, if you go down here and look at the magnetometer, it reacted too. The X-ray flux ain't showing much. Okay. It didn't show anything. The KP index barely bumped up a little bit right around the time of that increase. Okay. Again, this is just another representation of the KP. It's saying the same thing. Alright. Now this is the proton flux. Okay. Anybody that knows anything about atoms or how they're made, particles, that kind of a thing, you typically have protons, neutrons, and electrons that make up these atoms, right? So when you talk about proton flux, that we're talking about protons, the amount of protons. If you look right around the 10th, it looks as though right there when we had that spike, that they dropped out. The protons dropped out. Because if you look at this other part of this model, you can kind of see how they stayed and it kind of even spiked right there, but then they dropped out. What happened right there? I don't know. I can just tell you that that's different. It's an observation, and it's only talking about the The protons there. Okay. Now, this is the electrons. Oops. Stupid.
Well, my rough and bumpy skin is on the back of my arm. It's nothing I've ever tried before.
Okay. Yeah. Get you some Gold Bond, guys. Sorry. Again, I'm going to fix that today. I'm going to get into my phone here and figure that out. Anyway, you got electron flux there, guys, and it definitely showed something. Something happened right there. I didn't see anything happening on the sun, so I don't know where that came from. But, yeah, something happened. So, and I'll give you guys a little update on it here on the end of this video. But, yeah, guys, that article, you know, I think everybody should go watch it. Go check out Scott's stuff. Definitely go check out Nicole's stuff. She's doing some good work over there. Go check it out. And also on the Russian explosions, you know, they had another one today. Okay, that's the second one at a different site. Huge power outage too today, guys, over in England. Obviously, you guys know what I'm talking about there. I mean, I'm not saying that any of this stuff caused that power outage. Could have had anything to do with it? Probably not, because I didn't see anything huge here. That's just something we always look at. I don't think it had anything to do with it. I'm not sure what caused it. I do know that I've seen a lot of 5+ earthquakes past few days. You guys should go check out Dutch Sense when we're talking about that kind of a thing, because he does an awesome job on that. And he actually even talked about 5+ earthquakes. So yeah, guys, I'm going to go ahead and end it there. I'll try to give you guys another update, bring you guys some more information as I get it. And God bless. Yeshua saves, and you can drink this Kool-Aid.
Bye.